Good day to all virtual attendees and fellow delegates. My name is Kimara Naicker, and I'm a PhD researcher and a member of the Quantum Research Group at the University of KwaZulu-Natal. It's with great pleasure that I get to present to you today a discussion around the topic of quantum-enabled business advantage. Quantum computing could be coming to your business soon, and I'd like to discuss some strategies to prepare your company for this paradigm-shifting technology. Quantum computing is nearing a phase of commercialization that may change our world. Early adopters of quantum's unique ability to solve certain types of problems may achieve breakthroughs that enable new business models. Visionary organizations should already be aligning with the emerging quantum computing ecosystem to become quantum ready. These forward-thinking enterprises should be exploring use cases and associated algorithms that address complex business problems. Quantum computing takes advantage of the laws of quantum mechanics found in nature and represents a fundamental change from classical information processing. By encoding information into quantum states, quantum computers may perform calculations we can only dream of today. Two properties of quantum behavior, superposition and entanglement, may allow quantum computers to solve problems intractable for today's classical machines. A classical computer uses binary bits that can only depict either 1 or 0. Instead, quantum computers use quantum bits or qubits that can depict a 1, 0, or any combination of the qubits' possible states. This is known as superposition. Therefore, a quantum computer with n qubits can have 2 to the power of n possibilities in superposition with one another. This supplies quantum computers with an exponential set of states they can explore to solve certain types of problems better than classical computers. What is entanglement? In the quantum world, 2 qubits located even light years apart can still act in ways that are strongly correlated. Quantum computing takes advantage of this entanglement to encode problems that exploit interdependence between qubits. The quantum properties of superposition and entanglement help enable quantum computers to rapidly explore an enormous set of possibilities, to identify an optimal answer that could drive business value. As future quantum computers can calculate certain answers exponentially faster than today's classical machines, they will enable tackling business problems that are exponentially more complex. And I've added a reference section later on where you can read up some of these applications. Despite classical computers' limitations, quantum computers are not expected to replace them in the foreseeable future. Instead, hybrid quantum classical architectures are expected to emerge that outsource portions of difficult problems to a quantum computer. Quantum computing appears to be on a path to potentially transform certain industries. For instance, current computational chemistry methods rely heavily on approximation because the exact equations cannot be solved by classical computers. But quantum algorithms are expected to deliver accurate simulations of molecules over longer timescales, currently impossible to model precisely. This could enable life-saving drug discoveries and significantly shorten the number of years required to develop certain pharmaceuticals. To profit from quantum computing's advantages ahead of competitors, forward-looking businesses are already developing expertise to explore which use cases may benefit their own industries. The time when quantum computers can solve business problems that classical computers cannot, often called quantum advantage, appears close at hand. Development of the quantum computing ecosystem is accelerating in anticipation of the opportunities the new technology will create. Startups and partnerships between researchers and technology providers are springing up to translate quantum research into capabilities suited to the business world. Technology firms developing quantum computers are already partnering with businesses to identify potential use cases, to develop quantum algorithms, and to test solutions on actual quantum computers. And yes, these do exist. This quickly growing engagement of businesses with quantum technology will accelerate the arrival of the first commercial applications. Not all quantum computers are created equal, nor do they solve the same problems. From the most limited to the most versatile, quantum computers are typically classified into three categories: quantum annealing, noisy intermediate scale quantum computing, and fault-tolerant universal quantum computing. The consensus of the scientific community, and again I've added references, is that quantum annealing will not offer a meaningful speed up over classical computing. Furthermore, quantum annealers are not on the development path that leads to fault-tolerant universal quantum machines. As a result, quantum annealers cannot be considered true quantum computers. In the near-term, noisy intermediate-scale quantum computers, they have the best potential to deliver business advantage, and many new algorithms are being adapted for them. Moreover, as this type of quantum computers scale up, they progress towards the ultimate goal of quantum computing, that is, a fault-tolerant universal computer that can handle important classes of business and scientific problems, often exponentially faster than a classical machine. Why tackle quantum computing now? Technological and competitive forces are bringing in the quantum age sooner than you might expect. Organizations paying attention today could take industry leadership away from those who are not. Here are reasons, or few reasons rather, why businesses are considering getting quantum ready now. Quantum computers are expected to transform industries because they have the potential to address exponentially complex problems that classical computers cannot. Future quantum computers could help achieve product breakthroughs in areas such as healthcare, finance, AI, and material sciences, just to name a few, enabling rapid market share gains and greater profitability for the visionary companies that adopt them. In this way, quantum computing's problem-solving capabilities could dramatically redefine competitive advantage, transforming business operating models and value chains that revolutionize entire industries. Consider a use case that a quantum computer could solve exponentially faster than a classical machine. Designing a purpose-built material for the electronics industry that's significantly lighter and stronger than current substances. The accelerated development of such a revolutionary material will position a manufacturer to outrun its competitors in short order. Moving up the learning curve, this newly quantum-enabled market leader could quickly gain increasing advantage over competitors by fine-tuning its breakthrough material, as well as by expanding into new materials customized for other applications. While hypothetical, this example illustrates how a steep learning curve could make it extremely difficult, even for so-called fast followers, to quickly catch up with first movers in this business, potentially resulting in a winner-take-all scenario for certain industries. Even if catching up were possible for a specific use case, it would likely be associated with great costs related to, for example, buying in-house expertise or procuring access to the best infrastructure. Another factor to consider is building an in-house quantum center of competency will take time. Although most businesses have heard about quantum computing by now, many do not have the talent or expertise required to take advantage of its impending business transformation, and acquiring it won't be easy either. The supply of quantum computing talented is limited, with fierce competition for skilled resources. Once the right people are on board, it will likely take years to develop a deep understanding of quantum computing's potential impact on a given business. Recent technological shifts, such as the almost decade-long migration to GPUs to accelerate big data workloads, underscore the time it takes to build competency when adopting a new technology. Given quantum's potential for radical industry transformation, exponential problem-solving capabilities, and the difficulty to obtain quantum skilled resources, leading enterprises should consider acting now. What could the commercialization of quantum computing mean for your business? Let's discuss 3 areas that could add business advantage: quantum simulation, quantum optimization, and quantum-assisted machine learning. Because quantum mechanics describes how nature works at a fundamental level, quantum computing is well suited to model processes and systems that occur in nature. This capability could open the door to developing longer life batteries, or rapidly biotech like startups rapidly developing drugs tailored to an individual patient, or fertilizer could be manufactured more efficiently. The possibilities are endless. The art of solving optimization problems involves finding the best or optimal solution in a situation where many answers exist. Take the example of building a package delivery schedule. Mathematically, more than 3 million possible combinations exist for scheduling 10 deliveries in time slots. But which schedule represents the optimal solution, considering timing requirements of the recipients, the shelf life of transported goods, or potential delays? Even when applying approximation techniques, the number of possibilities is still far too large for a classical computer to explore. Think about it. Even the world's greatest supercomputers also run out of storage. As a result, classical computers today take extensive shortcuts to solve optimization problems of significant size. Unfortunately, their solutions are often likely suboptimal. Many businesses could benefit from quantum optimization, and these include healthcare providers, telecommunications, consumer product and retail companies, university scheduling classes, and financial services is my favorite. Also, disclaimer, while no one has yet delivered a mathematical proof confirming that quantum computing will confer an exponential speed up for optimization problems, researchers are working on demonstrating this heuristically. Forward-thinking companies are already exploring solving optimization problems using quantum computing in their quest to leap ahead of competitors. Their foresight may turn to advantage after the first demonstrations of quantum advantage in optimization are confirmed. I've taken a snippet from an IBM article, which I've added in the references, but here's how JP Chase explores quantum advantage in collaboration with IBM. Given the abundance of investment vehicles, portfolio combinations, and potential financial scenarios, today's financial advisors cannot build and manage a tailored financial portfolio that has evaluated virtually all possible options. But quantum computers could investigate the wide array of investment options, running valuation and risk scenarios tailored to each client's specific performance criteria. In this way, JP Chase, in collaboration with IBM, is already experimenting with quantum computing in search of quantum advantage in areas including trading strategies, portfolio optimization, asset pricing, and risk analysis, to name a few. The stakes are really high. If a financial institution could gain competitive advantage using quantum computing, it could bring about billions for both clients and shareholders before the competition is able to catch up. Now, quantum-assisted machine learning. Given its ability to explore a large set of possibilities that a classical computer cannot process, quantum computing expands the adaptness of AI. In fact, a relationship between AI and quantum computing is beginning to flourish, a virtuous cycle of advancement in both fields. For example, quantum algorithms can enhance machine learning in the area of data clustering, while machine learning can be used to better understand quantum systems. Quantum-enabled computers could eventually pervade virtually all industries, providing professionals with advanced, proactive decision support, employees with targeted responsive training, and customers with uniquely tailored adaptive relationships. Businesses that adopt near intermediate scale quantum computing early enough could outrun their peers by dramatically innovating operating models and creating first-of-a-kind products. If you want to be on the front line, now is the time for your business to become quantum ready. So let me discuss a few tips that I've gathered from reading a few different articles on how you can prepare your enterprise. Number one, select your quantum team. Chances are organizations need to learn more about the prospective benefits of quantum computing. And I suppose you could get started by designating some professionals as a quantum team and give this team the task of understanding quantum computing, its potential impact on your industry, and how your competitors are responding. And also, most importantly, how your business might benefit. This team can, report periodically and share this information and educate your organization and align progress to strategic objectives. Secondly, begin identifying quantum use cases and associated value propositions. Once your quantum team understands how quantum computing works and how it could address your business challenges and opportunities, have them start identifying specific areas where quantum computing could put your organization ahead of your competitors. Evaluate opportunities based on the unique capabilities of quantum systems and their ability to accelerate advantage. Have your team monitor the progress in quantum application development to track which use cases should be commercialized sooner than others. To ensure your quantum studies linked to business results, select your most promising quantum computing applications, and such as breakthrough products and services or new ways to optimize your supply chain. And third, this is my favorite, experiment with real quantum systems. Demystify quantum computing by trying out a real quantum computer. Have your quantum team get a sense for how quantum computing may solve your business problems and interface with your existing tools. A quantum solution may not be a fit for every business issue. Your team needs to focus on solutions of highest priority use cases that classical computers can't practically solve. I mean, we don't want to be wasting time delegating duties to quantum computers where classical computers can solve these better. My fourth point is to chart your quantum course. And by this, I mean construct a quantum computing roadmap with the purpose of pursuing problems that could create formidable competitive barriers and sustainable business advantage. To accelerate your organization's quantum readiness, consider joining an emerging quantum community, and there are many of these. This can help you gain better access to technical infrastructure, evolving industry applications, and researches that can enhance your development of specific quantum applications. And lastly, maybe most importantly, is to be flexible with your quantum future. Quantum computing is rapidly evolving. Seek out technologies and development toolkits that are becoming the industry standard and around which ecosystems are merging. Realize that new breakthroughs may cause you to adjust your approach to your quantum development process, including changing your ecosystem partners. Be aware of how your own quantum computing needs may evolve over time as well, particularly as you improve your understanding of which business issues can benefit most from quantum computing solutions. Here are some questions you can ask yourself with regards to your enterprise. What is the level of knowledge regarding quantum in your organization? How might your organization be disrupted by quantum computing in the future? What simulation, optimization, or machine learning problems are central to your company's competitive advantage? And what if your competitors capitalize on quantum solutions before you do? Now, what must happen to fulfill this quantum promise? Despite the flurry of activity and rapidly growing interest in quantum computing, major breakthroughs with real-world applications are probably years away. Let's be real about this. And one reason for this is the fickleness of subatomic matter. Qubits are extremely delicate, and even a small disturbance knocks particles out of quantum state. This is known as decoherence. That's why quantum computers are kept at temperatures slightly above absolute zero, colder than outer space even, since matter becomes effectively more stable the colder it gets. Even at that temperature, qubit particles typically remain in superposition for only fractions of a second. So it's quite the challenge. A next major benchmark will be the successful implementation of logical qubits. Logical qubits specifically that can maintain a quantum state longer than is now technologically possible. Logical qubits are necessary for those fault-tolerant computers I mentioned earlier on. And this fault tolerance is the true test of quantum computing's utility. The logical qubit is likely to arrive sometime in the next decade or so. Another open question is economic. How will the arrival of the quantum age impact the number, categories, and quality of jobs in the decades to come? It's difficult to say right now how big an industry quantum computing will eventually be. But currently, a major skills gap has left nearly every quantum organization struggling to find qualified recruits. Here is a picture of the IBM, one of the IBM quantum computers. And how does this masterpiece work? So you enter your instructions on your classical computer. This is then passed to the quantum computer hosted on the IBM cloud. The instructions are converted into microwave pulses, which control the qubits and alter the quantum states. Then, as the pulses travel through the cables to the qubits, they are cooled to around absolute zero. This is around negative 273 degrees Celsius. After the pulses interact with qubits, any changes are transmitted back through the cables where they are converted into data that our classical computers can interpret. And that's how you run a quantum computer on the cloud. So lastly, I would like to say you should try out a quantum computer on the cloud. There are many available, and just to name a few, they are hosted by Microsoft, Google, Alibaba, Amazon, and IBM Q is my favorite. So that's all from me. I would like to say you should join an emerging quantum computing community. And if you would, here are some relevant articles and those references that I mentioned earlier in my talk. And if you would like to contact me, that's my quantum research group website. my LinkedIn handle, and my email address. Thank you. Cheers.